Yeah, so that's a position time graph. So we know that speed, velocity are the rate that your position is changing with respect to time. So I would do something along those lines, like speed is the rate your position changes, and then put something about this rate is shown by the slope. All right. So yes, remember that relation? Okay. So then in the how section, I'm going to use start with the valid physics equation, which is V equals delta D over delta T, which is slope, which equals rise over run. Right? Yes? Okay. Probably the easiest one to do is the red section. What's the slope of the red section? 0. Right? Yes? Do I even need to do that part? Do that one? No, we need to see it. Good. That's what I thought. And then the green here, we need to do the rise over the run. So let's see, each of these blocks is what, 10 on the position. Each of the little blocks is 10. And on the run, each one is a second, it looks like. So if I take this point here, I have the time looks to me to be 22 seconds. And the position, I'm going to go with 210 meters. Would you guys agree? I'm looking for one that hits as close to a cross as I can, so I have as little estimation as possible. I'm going to go with this one here, and that would be 35 seconds and 350, 360, 370. Does everyone agree? Okay. So then back here, for the green section, I'm going to do that the speed is delta D, so that's my final minus my initial. Time final minus time initial, which is the same as rise, same thing you do with rise and run, right? Because it's the same idea. So 370 meters minus 210. 210 meters over 35 seconds minus 22 seconds. Should we do the last section too, or do you think you could do that one? Is this going to, oh, and you can see what type of value is that going to give me up here? Positive or negative? Positive. And that's good because I know, just because I've taken other courses, that that's a positive slope, right? So what type of slope does the blue section have? Negative slope. And so I would expect to get a negative answer when I did the slope of it. Should we do the slope, or do you guys feel you're good on the slope, on figuring out that slope?
Does it matter when, because I know for this one you have to finish maintenance, so does it matter like which point you subtract from which?
Always do final minus initial. So always do the larger time minus the smaller time. Yeah, so you can always think of later minus earlier. That'd be a way to categorize them. Because you can never, we can have negative position, we can have negative velocity. When we get to we'll have negative acceleration, negative forces, all these things. We can never, ever, ever have negative time. Because it's talking about how much time has passed while something happens. So that can always be, 35, 20, okay, that's the order I've got to put them in. Over here, let's say I picked a point in here, that's 50, and then I picked one that's 70. It's going to be the 70 things minus the 50 things to give me a positive time. If you ever get a negative time, go back and look and do something messed up. Move on to the next type of problem. Okay. All right, so I'm assuming you guys know who Pac-Man is. So we're going to time to get the speed of that Pac-Man, and he's just going to loop when you finish getting speed of it in a few different units. We'll see about that. And ready to start the program, click the green button, finish calculation, hit end to submit your results. All right. So we've got Pac-Man here moving. Notice our distances are in centimeters, right? So where do we want, when we start timing, what location would make life easier? 0. Doubt we can get 0, right? Should we try? I think we're going to have to wait for another cycle. We'll try our best to get 0, right? And then we could stop it, and I think as long as we stop it on a whole number, life will be easier. Okay? So, we know, and again, I would have probably almost identical explanation here in my y. That speed is the rate your distance or position changes. And some people might put after that with time, but the rate kind of determines the time, right? By saying rate, unless we're in calculus class, we usually mean how something changes with time. In calculus, it might be how does the volume change with the height. That would be a rate also, but we're not going to do any calculus unless you want to. We won't do any calculus. I might something to bring it down here. The faster he moves, the longer distance in a set time. So just remember something in your y to bring it to the exact problem. Okay? Yes. Yeah. Whatever we do as in class, that test will reflect that. Does that make sense? Yeah. All right. So let's get some data on our Mr. Pac-Man here. Can somebody write it down? Just keep track of it when we start. Oh. I finally got close to 0. What number do you want me to try to stop on? Anybody? 50? We'll try. All right. So we're gonna we said that his initial time was 0, right? And that's the final time. what does that little m mean in front of the unit of seconds?
Millisecond.
Millisecond. That, and if you didn't know, if you saw that and you went, I have no idea what that little m means, turn your equation sheet over and look at the metric prefixes. And you'll see it says milli, and it means times 10 to the minus third. Remember millimeters and things like that from like middle school? And then he went 50 centimeters. Okay. I don't like working in weird units, I like working in base units. So I'm gonna I'm gonna write things down in base units. So I'm saying his change in time was 0.5, wait a minute, I gotta look at it again. No, so 3 places, 1, 2, 3, so that's 5.55 seconds. His distance traveled, get rid of the delta there, sorry. His distance traveled was 0.5 meters. I converted 50 centimeters in my head to meters. Is that okay? Okay. I'm going to use the physics equation that speed is that I have this equation which says velocity is displacement over time, and therefore I know that speed is distance over time. And now it's a plug-in, right? 0.5 meters over 5.55 seconds. And that gives me 10 something, 9 something. 9 something, I'm guessing. Maybe 9.9. Oops. Wrong key. Equals 0.090 meters per second, which I might also write as 9.01 centimeters per second, depending upon what units they ask for.
That's for speed, you don't have to say the direction.
Right, there is no direction. Yeah. If it asks for velocity, then I would have come up with positive. And this would have been positive 0.5 meters, right?
What do you said like east?
I could have said east also, depending upon what the convention was. Yeah. If they gave me, hey, Pac-Man is heading east, then I'm going to give it an east.
Yeah.
If they don't, since I'm dealing just with 2 directions, I can go positive, negative. What time are we over today? You want to do this relative speed problem, right? I don't know if we'll get all the way through it. Nope. Actually, let's do this one instead, just because in this one we don't have to take any data, and in the other one we'll end up taking data, which will take us a longer time. Is that okay? Okay. So we have a thing in the ground frame of reference. The train is moving to the right, and the worker is moving to the left. In the train frame of reference. In the train's frame of reference, what are the 3 velocities? So, the y, I would focus in on things like all velocities are determined by your frame of reference. and the speed and direction can be different. In different frames of reference. Because in the Earth's frame of reference, the train's going one way and she's going the other way, right? And the guy standing watching on the other side of the road isn't moving. From her frame of reference, the train may be going the opposite direction. Or from the train, she may be going the other direction. So there's lots of, not only can how fast you're moving, which is the speed, but also in what direction it's moving. So in the how section here, I'm going to start off by grabbing my equations from the equation sheet, which says the velocity of AB equals the opposite velocity of BA, and the velocity of AC equals the velocity of A to B plus the velocity of B to C. Those are my two relative motion equations. Here they tell me the velocity of the train with respect to the Earth, and they tell me the velocity of the worker with respect to the Earth. So which way do you guys want to call positive? To the right? Yeah, okay. So the train is positive 15 and the worker is negative 1.2. Right? So worker Earth is negative 1.2 meters per second. Train is positive 15 meters per second. And they want to know, what we don't know is the velocity of the Earth with respect to the train, and we want to know the velocity of the worker with respect to the train. Right? We can use that first equation for the Earth to the train. Because if the train to the Earth is positive 15 meters per second, using this first equation, we get the velocity of the Earth to the train as negative 15 meters per second. Yes? A to B is the negative of B to A. All we do is swap those. The worker to the train is a little more complicated. We're going to have to use the second equation. So we want the velocity of the worker to something plus the velocity of that something to the train. In both these cases, we can do it with respect to the Earth.